and welcome to another WJEC A level physics question. This time is question 4 from May 2014's PH1 paper. It's a question about potential dividers. First of all, we're asked to define the potential difference between 2 points in an electric circuit. So this standard definition that we need to learn. It's the amount of electrical energy converted to other forms. Oops, I missed out energy. Per unit charge moving between those 2 points. Common mistake that people make is that they forget that per unit charge or per coulomb part. Next, we got 3 resistors connected in series. They have PDs across them, V1, V2, V3, and the supply has a PD across it, V supply. So all we're going to do here is complete the equation that relates all of those potential differences, and that's simply that V1 plus V2 plus V3, when added together, they give V supply. An equation that we wrote down is an example of which conservation law. This is conservation of energy. Because if we remember, a volt is a joule per coulomb. So it's energy per unit charge, as in the definition for potential difference. For part C of the question, we get a different circuit with a 9-volt supply connected to a resistor network consisting of an unknown resistor R connected in series with a parallel combination of 2 12-ohm resistors. We're told that with the switch open, the ammeter reads 0.5 amps, and we've got to show that R is 6 ohms. Well, if the switch is open, we can ignore the right-hand resistor. We've simply got a series circuit. Let's first of all calculate the PD across the 12-ohm resistor by using I times R. 0.5 times 12 is obviously 6 volts, which means that the PD across R must be 3 volts. And then finally, R will be V over I, 3 over 0.5, same current everywhere in a series circuit, gives us the required 6 ohms. The switch is now closed, and we've got to calculate the new potential difference across R. Well, the first thing to note is that 2 12-ohm resistors in parallel is equivalent to a 6-ohm resistor. You can show that quite easily with the resistance formulae. 1 over 12 plus 1 over 12 is 2 over 12 or 1 over 6. So the parallel combination is 6 ohms. The total resistance for the circuit now, let's call it RT, will be 12 ohms. We simply got 6 ohms for R and 6 ohms for the parallel combination. We can now either go down the route of calculating the current in the circuit and then working out the potential difference across R, or we can just simply realise that if the 2 12-ohm resistors are equivalent to a 6-ohm resistor and R is 6 ohms, then the potential difference of 9 volts is split evenly across the combination, 4.5 volts across R and 4.5 volts across the parallel combination. So that would be the quickest way of doing it. So I'll just put equals share there in brackets. Now we've got to calculate the new current through the ammeter. So the examiners ideally wanted us to do it a ratio way and then calculate the current afterwards. Now to find the current, we simply use V over R. Still 9 volts, total resistance 12 ohms, and 9 over 12 is 0.75 amps. More 12-ohm resistors can be connected in parallel with the existing 12-ohm resistors, and we've got to determine the total number of 12-ohm resistors needed for the current through the ammeter to be 1.2 amps. Well, let's work out what total resistance we need for that. So we've got V is 9 volts, and the current that we require will be 1.2. So that gives us 7.5 ohms total. So let's call it RT. That means the resistance of the parallel section is going to be 1.5 ohms, because remember R hasn't changed and R is still 6 ohms. So what we could write down here is an equation along the lines of 1 over the total parallel resistance is going to be n over 12, where n here will be our number of resistors. That comes from 1 over 12 plus 1 over 12 plus 1 over 12 n times. So quick bit of rearranging. N is going to be 12 times 1 over the 1.5 we worked out up here, and therefore n is 8 resistors. Thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.